this problem very fast. Using Lagrangian mechanics, I have only one coordinate theta, one q theta. Write down your kinetic potential for one mass, which is mgy here, which is L sine theta or cosine theta. Done. Just theta double dot equals, right? Gonna be just in a minute to write down the equation for this guy. That's perfect. You cannot do that within the framework of Newtonian mechanics. You need to work a little bit, right? Now, no, you're asked not only to solve the problem, but also to determine the constraint force, the force in the rod. This is required. For some reason you want it. Okay? You want to make sure that the rod will not break under fast maneuver or something. Okay? So I want to account intentionally for the constraint force. Now this is your desire, so we're going to live with that. So your Q's, I can have my problem as follows. Q1 equal theta subject to no constraints. Yes, you can do that. Instead, because I want the constraint force, I will solve this problem. I have two Q's. Q1 is x, Q2 is y for the second mass, subject to x squared plus y squared equals L squared. Any question about that? Any question?
But do you need to solve it with two different ways?
Yeah, you can solve it this way, you can solve it that way. Here you will not see the constraint force at all because you did not account for the constraint. You accepted it, right? Over there, you added more degrees of freedom and more unknowns, and as a result, you will get the constraint force at the end. Yes,
And why Q1 is X, not Y?
It doesn't matter, the numbering, it's up to you. Let's go to this. M1 here, M2 to be just consistent, if you like. This is the numbering of the Q's has nothing to do with the numbering of the bodies, right? We actually have another counter, right? We typically use I from 1 to large N to denote the number of bodies and particles. And J from 1 to little n, this is the number of Q's, right? And K from 1 to M, this is the number of constraints. Do you have any question? Yes, Jeff?
Could you also write it in terms of theta constraint and use theta?
Oh yeah, you can do that, say X and theta. Yeah, sure. Any 2 degrees of freedom. Okay, let's do it. This part is pretty easy, and of course you can do it alone now. So we're going to do this part together. It's a holonomic constraint, right? Anybody doesn't see that it's a holonomic constraint? Any problem with that? Okay. But I don't care. If it's a holonomic constraint, I'm just going to differentiate it. Differentiate this with respect to time, please. I get 2x, x dot plus 2y, y dot equals 0. Now it looks like a non-holonomic constraint. Looks like, but I know that it's intrinsically a holonomic constraint. Okay? And in particular, I'm interested in the velocity coefficients. What is multiplied x dot, what is multiplied y dot. Okay, let's turn our crank. R of the first mass is simply xi. R of the second mass is simply yj. I just need velocities, please. So r1 dot is x dot in the I direction, r2 dot. I'll give you some time to write. And then I need kinetic and potential. Kinetic is 1/2 m1 r1 dot square, so this is x dot square, plus 1/2 m2 r2 dot square, this is y dot square. Potential. What's the potential do we have? What's the potential energy?
mgl cos of theta.
M2G, it's y. So I'm almost done. I have my Lagrangian. You can do it here. So Lagrangian is kinetic minus potential is simply 1/2. I will yeah, just assume M1 equals M2 for the simplicity here. So I have m x dot square plus y dot square minus the potential, which is mgy. Your x equation, please. What's that? What's the x equation? Lagrange equation, d by dt, partial L, partial what?
X.
X dot minus partial L, partial x equals your non-conservative in the x direction plus your constraint. Okay? What's my constraint? I have only one constraint, so it's lambda times the coefficient of x in the constraint equation. Let's substitute, please. Partial L, partial x dot, this is simple. This is simply mx dot. There is no dependence on x, and I don't have any non-conservative forces all the way. Lambda is unknown, and what is ax? Ax is the coefficient of x dot,
2x.
the coefficient of the velocity, okay? In the constraint. Here is the constraint, the coefficient of the velocity is this guy, this is ax. This is 2x. So you immediately get the x equation, it's mx double dot equals 2 lambda x. Very easy. Okay? Any question, please? I'll give you some time to write. Yes, Ishkan.
And the green line, the very last that you said minus mgy, shouldn't be half
Why half?
because m1 and m2 are equal and we are only
No.
interested in m2.
No. This is, I assume that m1 equals
To
m2
M2.
equals m, right? So this is
Oh,
1 of
okay.
m, 1 of m.
Right.
Right? Now the y equation, d by dt, partial L, partial what?
Y dot.
Y dot minus partial L, partial y equals your non-conservative in the y direction, I don't have any, plus your lambda times a y, the coefficient of y dot, the velocities in the constraint. This is very easy. This guy is my dot. Partial L, partial y. There is some y dependence here. This is negative mg. And this guy is the coefficient of y dot from the constraint. Here it is. It's 2y. So this equation gives you my double dot equals negative mg plus 2 lambda y. Okay? Any question about that, please? Any question? So how many unknowns do we have in this problem? How many unknowns? How many unknowns? Well, what are these? Let's list our unknowns.
Lambda, x. and
Lambda
y.
for sure is unknown. Very good. And then,
The two dots.
yeah, every double dot is unknown. X double dot, all
Y.
your accelerations are unknown. And Y double dot, this is 3 unknowns. So hopefully we should get 3 equations. I just boxed 2 equations out of the Lagrange's equation. So you need one more equation.
Constraint equation.
The constraint equation, don't forget that you have an equation here, right? It's good if you, or will be convenient if you differentiate it one more time to write in terms of x double dot and y double dot. So everything will be in terms of the double dots. So if you differentiate one more time, I will get 2x double dot, 2x double dot plus 2y double dot plus 2 x dot squared plus 2y dot squared. Actually, you can divide by all the 2's. But this is the third equation. So here we have x double dot plus y double dot plus x dot squared plus y dot squared equals 0. 3 equations, you can write them on our standard form. Mass matrix times x double dot, y double dot, and lambda equals something on the right hand side. And you can fill it very easily. The first equation is m times x double dot, no y double dot, and negative 2x, no right hand side. The second equation is here m negative 2y and negative mg. The third equation is xx double dot y double dot no lambda negative x dot square then y dot square. Okay? Then you can solve these three equations algebraically. They are linear, right? Linear equations. To get x double dot, y double dot, and lambda. Once you get the lambda,